So in section 10-1, we're again dealing with area. We're expanding our knowledge a little bit to not just rectangles, which we dealt with in 1.8 on Monday, but we're also then saying that we can find the area of parallelograms. Okay, that's really the new concept today. So from Monday, you guys know that the area of a rectangle is base times height. And you guys knew that before you came in here on Monday. Okay, so we know the area of a rectangle is base times height. And remember, we wrote this in our notes on Monday, that base and height always have to be perpendicular to each other, 100% of the time. And the other thing I said here was that base is always a side of your polygon. The height is sometimes the side of a polygon. Like up here, the height's a side. But down here, the height is not. Okay? So, we know that the area of a parallelogram is actually given by the exact same formula, base times height. Okay? How does that come about? Well, essentially what they're doing here is they're taking a rectangle and simply taking this portion here, cutting off this triangle and kind of tacking it onto the end over there. Okay, that's how we're making our parallelograms. All parallelograms can be basically turned back into a rectangle that has the same base and the same height. Okay? Key thing you need to remember about a parallelogram is that the height, again, always has to be perpendicular. And so the height is probably, I shouldn't say probably, it's always going to be that perpendicular distance between one set of bases. Okay, one set of parallel lines. So looking out here, again, if your base is this side of this parallelogram, then your height has to be this altitude between these two bases. It's got to be perpendicular to that base. Now notice, they didn't change or turn that parallelogram. It's the same parallelogram in the same place, but now they're saying, well, what if we want this side to be our base? So just like I was saying with triangles on Monday, we need to kind of extend out that side so that we know where that line needs to go. But now this is our height. It's now that altitude, that distance from here to that line. And so, again, height is exactly what you think it is in everyday language. Okay, it is measured perpendicular to the ground. Your height is the distance from the bottom of your feet to the top of your head. Okay? How tall you are is when you stand up straight and tall, essentially, how tall you are. You know that measurement. You understand that concept. Okay? So the height of a shape is going to be the same as the smallest door that shape can be slid through on its base. Well, looking at that second one, let me flip it around here. If I wanted to slide this through a door on its base, well, this is the base, and so therefore the door has to be at least that tall. That's why that is then the height of that parallelogram. Okay? Making sense? Why that height has to be out where it's at? Okay. All right, so let's take a look here. We want to find the area of this parallelogram. Well, again, we have 5 points to earn in every problem, so we need to start out by writing down the area formula for a parallelogram. Area equals base times height. Now we need to plug into that area formula. So what are we going to use for our base? 5, very good. Could we use 4.5? it's a yes, but, right? Yes, but. We could use 4.5, but we would have to have then the corresponding height for that measurement, which they don't give us that, right? They don't give us that. They only give us the corresponding height for 5 to be our base. 4 is then our height. Again, here's our base. Here's our height. And so our area is going to be 20 square inches. Okay, questions? Easy peasy. Let's go to the next one. On our next one, again, it's a parallelogram. Area equals base times height. There's our formula. What are we going to use for our base? Two. Very good. Remember that the base has to be a side of our polygon. So that means we only have two options for the base, either 2 or 4.6. Well, there's only one of those that we have the perpendicular height associated with it. We know the height of this parallelogram relative to that 2 as its base. So our height is then 3.5. So if you take 3.5 times 2, what is our area? 7 what? Square centimeters. Okay? Okay, now, this problem, I really actually enjoy this problem, but the point being on this problem is that you're given certain information, and we're not just trying to find the area. We actually want to find this length, DE. I'm going to call it X for now. We're trying to find that length. Now, take close attention to that length, DE. It's perpendicular to AB. So, if we knew the area, because remember, this is a parallelogram, so area equals base times height. And so, if I knew the area, then 9.4 would be my base, and X would be my height, right? Okay. Well, I can't solve that equation for X because, again, I don't know my area. Did they give you more information? Yes. We have this as our base with 9 as its height. Okay? And so we actually can find the area for this parallelogram by using 13 for the base and 9 for the height. All right, so 13 times 9 gives us 117. All right, so that is our area. Again, that's not what they asked us for. So we've got to take that area and plug it in for the area in our other equation. We now know the area of that parallelogram. Therefore, we can now solve for X. How are we going to solve for X? It's multiplied to X, so we are going to divide by 9.4. All right, so X equals what? 12.4. Does it come out exactly 12.4? 12.446, so 4.5 if we round it out to 2 decimal places. Okay, and so that means DE equals, well, actually, DE is approximately, now look at the instructions. They do say to find DE to the nearest tenth. So you were right in saying that it's going to be 12.4 because I rounded it. You can't round it twice, right? I already rounded it to 2 decimal places. I can't use that to round again. The correct answer should be the 12.4 inches because it was originally 12.44. Okay, oops. Yeah, inches. Inches is right because we're finding a length, DE. Questions? right, let's see if you guys can do this one on your own. Discuss it with your neighbors. Ready, set, go. Okay, so what should we be doing here? Well, there's a couple of different ways to do it. You could draw a picture just like we had in the previous example. Sometimes people have a hard time visualizing what's going on and have a hard time drawing that picture. So this time, we're not actually going to use the picture at all. What we're going to do is we're going to say, well, we know we're going to deal with an area. So a parallelogram has two different sides. So sides have to be which part of our area formula? The bases. So we know those are the bases. Base 1, base 2. Okay. The height corresponding to 15 centimeters is 9 centimeters. So that's going to be our height for base 1. We are then looking for the height for base 2. Right? So let's go ahead and say area equals base times height. The area is going to equal, well, if our base is 15, we know that our height is 9. The other formula, area equals base times height. Area is going to equal, well, if our base is 18, we don't know that height. That's what we're looking for. Questions on my setup? Well, we can actually solve for the area, right? Now, to be honest with you folks, you wouldn't have to even solve for the area right now if you didn't want to. Because we know that the area equals 15 times 9. Whatever number that is, area equals 15 times 9, right? So you could, if you wanted to be fancy, and just say, oh, I'm going to plug 15 times 9 in for A. It's the same thing. Okay? I'm going to divide by 18 on both sides to solve for H. And hey, looky here, I know that 9 goes into 18 twice. And so my height must equal 15 divided by 2, which is 7.5 centimeters. Questions? All right, let's go to the backside. On the backside, we are again dealing with triangles, and I discussed this on Monday. Where did the 1/2 come from? Why is it base times height and then times 1/2 or divided by 2? It's because the area of a triangle comes from the area of a rectangle formula. Okay? If I take a rectangle and I cut it in half, then that gives me a triangle. Well, that same thing is true because a parallelogram can also be turned into a rectangle. Okay? Any triangle then can essentially be turned back into a parallelogram. So in this particular case here, we have this triangle where the height is not a side of the triangle. It's not a right triangle. But they show us here, we could still say that we're dealing with a parallelogram by just drawing the parallelogram here, where this side is still the length of B. Okay, and so now we have a parallelogram, and we only have half of it. So again, it's still going to be 1/2 base times height for the area of that triangle. Okay, making sense where that's coming from? All right, again, we discussed that on Monday. So let's take a look at a couple of these. So finding the area of the sail. Well, what is the base of our sail? 13 feet 4 inches. Yep, there's the base of our sail. And the height of our sail? 12 feet 2 inches. The problem with doing this problem is we don't play with mixed units. Okay? We don't play with mixed units. We need to change everything into the same unit. And in my humble opinion, it is always easier to change everything to the smaller unit. That way you don't have to deal with decimal answers. Okay? So, how many inches are in a foot? 12. So, if I'm changing 12 feet into inches, do you suppose I'm going to get a bigger number or a smaller number? It's going to be a bigger number. Okay, so am I going to multiply by 12 or am I going to divide by 12? multiply by 12. So therefore, this is going to be, rather than 12 feet 2 inches, 12 times 12 gives me 144 inches plus 2 more, right? That's 146 inches for our height. Okay, well, the same thing we got to do for the bottom. 13 feet changing into inches means multiply it by 12. What is 13 times 12? I think it's 156.
Yeah, but 160 with the...
156 plus the 4 more is going to be 160 inches for our base. Okay. So our area is 1/2 base times height. So that's going to be 1/2 times 160 times 146. Well, I know that half of 160 is 80. So I can take 1/2 times 160, that gives me 80. And so now in my calculator, I've got to take 80 times 146. 11,680. Now that is in square inches, because we did everything in terms of inches, right? We need to convert that into square feet of material, because that's what they asked us for. So here's going back to that unit analysis. We've got to figure out how to change things into square inches. Well, first off, we've got to know how many square inches are in a square foot. So if I think of a square foot, this is 1 foot by 1 foot. How many inches are in a foot? 12. So this is 12 inches by 12 inches. So 1 square foot has how many square inches? 1 square foot has, you're finding the area of that square. Base times height. 12 times 12. 144 square inches. Okay? So when I convert this, I have my 11,680 square inches. I want the square inches to cancel. Well, I know that there are 144 square inches in 1 square foot. And so again, I put the 144 square inches on the bottom because I want the square inches on top to cancel with the square inches on the bottom. And so then we have 11,680 square feet divided by 144. So what do we get when we take 11,680 divided by 144? 81.1 square feet of material. Questions? Yes? Then the last example I'd like to go through today is this one down here, finding the area of irregular figures. Okay? And so like we talked about on Monday, we can take any shape and cut it into pieces, find the area of the individual pieces, then add them all back up again, and we get the area of the big shape, right? And so that's essentially what we want to do here. This is, I don't know, the outline of a house. Well, I don't know how to find the area of a house. But can I cut this into shapes that I know how to find the area of? What shapes? The square and the triangle, right? So that means for my equation, I want to write down that my area is going to be the area of a square. How do I find the area of a square? You could do s squared, or I'd also accept what? Base times height, because a square is just a rectangle, right? So I would accept s squared or base times height for the area of that square. You guys said s squared first, so I'm going to write that down. Okay, so area of s squared, that's the square, but I got to add to it the area of that triangle. And that triangle is going to be 1/2 base times height. So that is now the area formula for my house. Okay? Plug in what we know. The side length of that square is 6. So it's 6 squared plus 1/2 times the base of the triangle is also 6. The height of the triangle is 8. So I got a point for writing down my equation. I got a point for plugging into the equation. Well, now I need to simplify. So let's see here. 6 squared is 36. 1/2 of 6 is 3. What's 3 times 8? 24. And so 36 plus 24, area is going to equal 60 square inches. Questions?